Hey there! So, you want to learn Python, right? We're about to go on a super fast tour, breaking down the absolute essentials, the stuff you really need to know. And the best part? We're going to try and do it all in just 5 minutes. You ready for this? Let's jump right in. Okay, so here's the deal. We've got 15 essential concepts and just 5 minutes on the clock. It's going to be fast, it's going to be focused, but I promise by the end of this, you'll have a really solid feel for how Python actually, well, thinks. Let's do it. All right, first things first, we've got to cover the absolute essentials. I mean, before you can build a house, you need to know what a hammer is and what the blueprints look like, right? So we're going to start with the big question. What even is Python? And how does your computer know it's looking at a Python file? So what in the world is Python? The easiest way to think about it is that it's a language designed to be as close to English as possible. It's what we call high level, which is just a fancy way of saying you get to focus on your big ideas, not all the boring, nitty-gritty computer hardware stuff. And honestly, its biggest selling point, especially if you're just starting out, is how readable it is. The whole point is for the code to be clean and just make sense. Okay, but how does your computer know it's looking at Python code and not, say, a shopping list? Well, it's all about that little ending on the file name. You know how a text document ends in .txt or a picture might be a .jpg? Well, a Python script always ends in .py. That's the secret handshake that tells the computer, hey, treat this like code. Now, this is pretty cool. How do you talk to other people inside your code? You use comments. Anything that comes after a hash symbol or a pound sign is a comment. The computer, the thing that actually runs your code, it just completely ignores it. It's like it's invisible. This is your spot to leave notes for your teammates or, let's be real, for your future self who's totally going to forget why you wrote that weird line of code. It's so important for working with others. Okay, you got to pay attention to this one. This is the classic Python thing that trips people up. So look at these two examples. In a lot of other languages, that first one on the left, totally fine, but not in Python. No way. In Python, that empty space at the beginning of a line, that indentation, it's not just for making things look pretty. It is the structure. It's how Python knows which lines of code belong in the same group. It forces you to write clean code, which is kind of the whole point of Python's design. It's part of the grammar. All right, so we've got the basic layout down. Now, let's get into the good stuff, the keywords that actually give your code power and make it do things. You can pretty much think of these as the action words, the verbs of the Python language. First step is def. Whenever Python sees def, it's a signal that you're about to define or create a function. So what's a function? It's just a chunk of code you give a name to, so you can use it again and again. You write the logic once, and then you can call it whenever you need it. It's all about not repeating yourself. Super efficient. The great thing is, you don't have to build everything from the ground up. Python comes with this huge library of pre-written code, and we call these modules. The import keyword is basically your key to this giant toolbox. It's like saying, hey, I need to do some heavy-duty math, grab me the math toolkit. Or, I need to work with dates, pass me those tools. You just import what you need, and boom, you've got new powers. So what happens when stuff breaks? Because trust me, your code will break. That's where try comes in. You wrap any code that might fail inside a try block. If something goes wrong, if you get an error, which we call an exception, your program doesn't just crash and burn. Nope. Instead, it jumps over to an except block where you can tell it exactly how to handle the problem. It's what makes your programs tough and reliable instead of fragile. So we've got the structure down, but what are we actually structuring? Data. Let's talk about how Python stores information, how it works with it, and how it compares it. This is really the heart and soul of what your programs are going to be doing. Now, when you're dealing with numbers, they're not always going to be nice, clean, whole numbers, right? For anything with a decimal point, think 3.14 or a price like 99.95. Python uses a data type called a float. It's just short for floating point number, and it's what you'll use for pretty much any math that involves fractions or decimals. Okay, this next one is a huge heads up for anybody starting out. When you ask a user for some information with the input function, Python will always, and I mean 100% of the time, give it back to you as a string. That just means text. So even if the user types in the number 123, your program sees the characters 1, 2, and 3, not the number itself. If you want to do math with it, you have to tell Python to convert it first. Super important to remember. This right here is probably one of the most common mix-ups for new coders. On the left, you see a single equal sign. That is for assignment. It's like a command. It says take the value 10 and assign it to the variable x. But on the right, with two equal signs, that's for comparison. It's a question. It's asking, hey, is the value of x equal to 10? And the answer will be either true or false. So remember this. 1 equals tells, 2 equals asks. It's a massive difference. All right, we're heading into the home stretch. We've talked about handling single pieces of data, but what happens when you have a whole bunch of it? How do you organize it? And just as important, how do you write code that doesn't look like gibberish a month from now? Let's get into data structures and best practices. The most common fundamental way to group data in Python is the good old list. You make one with square brackets, and that's all it is, a collection of items in a specific order. You can toss whatever you want in there, numbers, text, you can even have lists inside of other lists. And the key thing is that it's ordered. So the first thing you put in is always the first thing, the second is always the second, and so on. So great, you've got a list. Now what? How do you actually do something with every single item inside it? Well, that is exactly what a for loop is for. It is the absolute workhorse for this kind of job. It just goes through your list, one item at a time, from start to finish, and lets you run some code on each one. It's unbelievably useful. Sometimes you don't need to go through a list, you just need to know, how big is it? How many things are in there? For that, Python gives us this super simple and handy function called len. You just give it your list, or any other kind of collection really, and it spits back the number of items inside. It's that easy. But what if you have a list where you absolutely, positively do not want any duplicates? Well, that's where another data structure called a set comes into play. A set is a collection where every item is guaranteed to be unique. So, as you can see here, if you try to add apple to a set that already has an apple in it, nothing happens. The set just ignores it. It's the perfect tool for when you just want a list of the unique things you've collected. And finally, how do you make sure you're writing good Python code? You know, the kind other Python programmers will respect. Well, the community has a whole set of guidelines for this called PEPs, which stands for Python Enhancement Proposal. The most famous one is called PEP 8, and it's basically the official style guide. It tells you the best way to do things like indentation, how long your lines should be, all that stuff. Following it helps make your code super readable and what we call Pythonic, which is pretty much the highest compliment you can get. And just like that, you've made it. That was a lightning-fast tour of Python's most important ideas. We've touched on syntax, keywords, how to handle data, and how to write clean code. In a way, we've just handed you the basic grammar for a whole new language. So the only real question left is, what kind of story are you going to write with it?